The next is resistors in parallel. So the same in series we connected R1, R2, R3 in series in the same wire, right? And here the resistors are connected in parallel with the battery having same potential difference of voltage V. The total current leaves the battery is split into three separate parts, right? Then I varies here, that is I1 current passing through the resistor R1, I2 current flows through the resistor R2 and I3 in R3. Due to this conservation of charges, the total current in the circuit I is equal to the sum of the currents. So I is equal to I1 plus I2 plus I3, and keeping the potential as constant here. Okay, it does not vary, only the current varies here. Then from Ohm's law, I is equal to V by R, I1 is equal to V by R1. So since V is constant, I2 is equal to V by R2, I3 is equal to V by R3, and hence substitute these three values in that equation. So V by Rp, which is equal to V by R1 plus V by R2 plus V by R3. So we get cancelled. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So when the resistors are connected in parallel, the sum of the reciprocal of the values of resistance of individual resistor is equal to the reciprocal of the effective resistance of the combination, right? The value of equivalent resistance in parallel connection will be lesser than the individual resistance. In series it is greater, and in parallel it will be lesser. In our home, all the maximum appliances, we connect the resistors in parallel connection, so that when one is switched off, the other can work properly.